So here, instead of a graph of position versus time, we're given a graph of velocity versus time. And so what this graph tells me is, so kind of like that problem I looked at earlier, we've got this car sitting on a track. So it can only go left or right. And at first, it's moving. It's telling me the speed. Velocity is speed. It's just cruising along this way at 10 meters per second. And it does that for 3 seconds. So if I know something has a constant speed, then I can say, well, if it started over here at 0 and it's moving at 10 meters per second, then 1 second later, right, distance equals rate times time. If I know the rate is 10 meters per second, and I know it moved along for 1 second, meters per second times seconds, the second cancels, that tells me it's covered a distance of 10 meters. So maybe right here, that's 10 meters away, 1 second later. And then 2 seconds later, well, it's just going to keep moving at 10 meters per second. So another second goes by and it's going to be over here at 20 meters. And that would be 2 seconds later. And then another second goes by and it's going to be over here, 30 meters from the starting point, 3 seconds later. Now, calculus 2, I talked about earlier, is the idea of areas. And if you think about this for a second, so if I just focus on this part of the graph here, 1 second later, I took that 1 second here and I multiplied it by the 10 meters per second. And that multiplication on the graph is actually an area. So the area on a velocity graph gives me position. And this is what calculus 2 is about. So area on a velocity graph is position. And often in physics, we call it displacement, position or displacement, displacement. Another term we'll use there. And I keep accumulating those areas and I get a total area after 3 seconds here of that 30 meters away, right? And then all of a sudden the car starts going backwards, and that's what this tells me here. So over here, I get a speed of negative 10 meters per second, which means the car starts going backwards on the track. And it does this for 1, 2, 3 seconds. So then it's gone backwards in this case. Let's see, rate times time. So in the second part of the graph here, so part 2, it moved at a rate of negative 10 meters per second for 3 seconds, which means it covered a distance of negative 30 meters. So if in the first 3 seconds it covered 30 meters, the next 3 seconds it goes 30 meters backwards and ends up back where it started there. So what would the graph of position look like? So if I were to graph to position here, over 1, 2, 3 seconds, so here's my seconds there, and this is my position, my distance, my displacement. And let's see, we get 30 meters away. So let's just go 10, 20, 30, and these are meters. Right, 1 second later, I calculated that it was 10 meters away. 2 seconds later, it was 20 meters away. 3 seconds later, it was 30 meters away. So its position graph looks like that for the first 3 seconds. And then it starts going backwards 10 meters per second, so that it every second it drops 10 meters backwards, goes 10 meters backwards, goes 10 meters backwards. So this right here should be the graph based on distance equals rate times time of what that looks like. And notice, what's the slope of this line here? Right, the slope of that line right there is this 10, that velocity over there. And so one point of this problem is here is just the connection between the idea of slope and the idea of area on a graph of a velocity function. So calculus 1 and calculus 2 are forwards and backwards. So calculus 1 is doing division, and calculus 2 is doing this fancy multiplication there. And they are inverse operations, which is part of this introduction here. They go together like multiplication and division. So actually, let's see if we can identify the right graph. Oops. So that's not the position graph. That's not the position graph. Ooh, I got a couple of different options here. I check this one. Why is this one right and that one wrong? Well, this one peaks at 10 meters away here. And I definitely calculated that after 3 seconds, at 10 meters per second, we are 30 meters away from where we started. And you can see this one peaks at 30. So that's got to be the right graph. Yours will be in a slightly different order, and you may have slightly different numbers.